Hello everyone, I am SANTHAN Kumar from AML department. Today we will be seeing about the Linux process management and the subtopics in it, overview of the fork, wait and execution. So let's get started. So these are the goals to be achieved in our video today. So we will be understanding the mechanism of the fork function, and we will be grasping the significance of the wait function, and we will be seeing the handling capabilities of the execution function. These are the contents we will be discussing in our video today. So we will be having introduction to the Linux process management system, and we will be having the understanding of the fork, and we will be exploring the wait function, and we will be seeing the execution function too, and we will be concluding our video. So first, what is Linux process management system? So actually process management system is nothing but organizing the operations and the services in organized managed in the OS. So our Linux process management system has an important role in our OS. So it will be representing the running instances of programs. It will be handling the creating, scheduling, and then stopping the many processes. So how efficient the process management is, that much efficient our computer is. So basically it will be improving the stability and performance of a system. Poorly managed process can lead to a severe damage or severe deadlocks. So coming to the fork, what is the purpose of fork? Forking is nothing but creating the same replica or duplicate of original process. So fork is a system called Linux used for creating new processes. So process duplication. Let's say you are running a process A, and then you have to run it in some set of 10 to 20 operations. Then what we'll be doing is we'll be forking the same operation A with the same process IDs, process files, and then everything. So that is what process duplication is in fork management. And then result we will be having some execution threads which are resulted to the duplication process of the fork. So this is the flowchart of the fork. So whenever we fork a particular system process, we will be getting a child process and the parent process. So parent process is the main program, and then the child program is the fork or duplicate process of the original program. So until the child program is exited, it will be waiting. So whenever once the system encounters a exit call, it will be continuing to the remaining processes. So as we have seen importance of parallel execution, you know that we are in a world with the parallel computation and multitasking supporting. So basically fork can handle some various cases of multitasking where CPU shares some several resources. So coming to the wait function, basically we are having process synchronization importance. So it's crucial for system stability and efficient in Linux process management systems. So basically as we have seen, like same the fork function, wait function also has some critical importance in the stability and efficiency of the system. So wait system call recall. So it allows parent process to wait until a particular child process is being terminated or some deadlock has occurred. So wait functionality, as we have discussed, it suspends parent process, synchronizing it with child process. So it will be suspending the parent process whenever the child process is running, and then it will be matching the system call whenever the main process gets the program handle. And then moving on to the significance in process management, it plays a crucial role as we have discussed. We have some synchronization importance, system call recall, and etc. So what is the purpose of wait function? So wait is basically nothing but system call in Linux, where we'll be calling some wait function, so that the wait function allows us to stop the parent process and then lets the child process to get executed. So basically here we can see waiting for child process. Whenever a parent process calls wait, it waits for its child process to terminate before continuing execution. So and then main important function of the wait is preventing zombie process. So whenever zombie process is there, the process doesn't terminate or stop perfectly. So what our wait does is it waits until the child process gets executed, and then wait prevents zombie process by collecting the exit status of terminal process. So and then we will be handling multiple child processes. So whenever fork we occurs, and then we will be getting some multiple child process. Let's say A has some child process B, and then B has some child process C. So what wait does it will be handling all the multiple child cases perfectly. So this is the flowchart of the wait function process state. So basically whenever a new process is created, it will be readied into the ready queue, and then if it is accepted by the CPU, it will be running and then terminated. But whenever we get a IO or event completion, so it will be going to the waiting state, and then where our wait function comes into play, and then after the waiting function it goes to running and finally terminated. So as you have seen basic example and the flowchart. Here is a real life example. In batch processing system, the parent process may wait for each child process to complete before the execution completes. So this is the significance in the process management of wait. So coming to the execution function, it's nothing but replacing the original function with some other function. So let's say you are having a process P1 or program P1. So what does execution function does? It will be replaced by some process P2 which has some higher priority order, etc. So here we can see Excel execute is crucial system call in Linux facilitating process replacement. So this is where we have discussed just now. So and then it allows to process to replace its current image with a new program. So basically, let's say we are having a process P1 and we have to replace it with P2. So it will be replaced with its current image to a new program P2. And then dynamic loading capability. So it will be loading the process P2 dynamically. And then it has some adaptability and transformations. So it can adapt to changing requirements by invoking execute. So let's say P1 has some execution files and some requirements regarding P1 files. When our P2 is replaced with P1, we will be getting the same process adoption by using execute function. And then objective of discussion is aims to explore functionality and significance of execution in Linux process management. So here we can see the purpose of execution. Execution is system call Linux used for the process replacement, and we will be replacing process image as we have discussed earlier, and then it will be loading the process dynamically. And then we have some various function calls or function variations in the execution. So it has variants like XL, EXCV, which will be handling those replacement cases in different ways. So this is the program X1. We have some text data which is related to X1. So program 1, and whenever we use the execute function, so same P1 is replaced by P2 with the text data. And we have some kernel space resources. They will be also be replaced whenever the execute function is called. So in a sample case, let's say in a shell environment, we are having execute function, so that commands will be replaced with the new commands whenever the user enters new ones. So this is the significance of the execute function in our Linux process management. Now let's see some examples related to the wait, fork, and execute. So here is an example program for the wait function, and then fork, and then execute. So coming to the fork, so let's say we are working with some PID ID, which is process ID. Whenever the process ID is 0, the fork will be failed because nothing is there to fork, right? And if the process is equal to 0, child process will be replaced with the same number, or else it will be replaced with the 0. So let's run it. So the parent process has child PID as 6880. Whenever it is forked, same duplication will be happened and the same PID will be assigned to the child process. And then coming to the wait function, so let's run it. So as you can see, the child process ID is 6897. Whenever the child process is terminated, the program handle goes to the main process. And then coming to the execute function, so whenever we are having a process P1, it will be replaced by P2, right? Before execution, it is some process, let's say some T1. After execution, it is T2. But same resources are being managed. So as we can see here, we have created characs, which is related to the LS. So basically the programs all will be listed there. So if the code finds the listed programs there, it will be replacing using the execution function, and then we will be having the new execution replaced function. So in this way we can see the example code implementation of the three functions. So and then coming to the uses, as we have seen, it improves those three functions may improve the system stability and importance. So basically we have got some foundational importance as we have discussed in Linux process management, and we have some enhanced system capabilities where some algorithms are being run by on the basis of this fork, wait, and execution, and we have some many applications in some apps or the operating systems and etc. So on concluding the session, we have got some basic knowledge on fork, wait, and execution, which are not just system calls but essential building blocks, as you have seen the uses, capabilities, examples. So this will be having some many lot of applications which are being developed in present day also. So they will be optimizing system performance so that the Linux process management gets improved day by day. So on this note, I conclude the topics fork, wait, and execution. Thank you.